Alright, so you have seen what AI 3D generators can do. You type in a prompt, maybe upload an image, and in a minute you get a model. It's cool, it's fast, but then you look closer. The topology is kind of a mess, the textures are a bit funky, and then you're left thinking, okay, but how can I make this usable in a real game? If you have hit that wall, you're not alone. There is a huge narrative out there that these tools are just for prototype, that they are not ready for serious production. Now this statement itself is debatable and completely depends on the kind of game you're making, right? It all comes down to the level of ultra realism and fine-tuning detail you're aiming for. In fact, some of you might remember my previous tutorial where I have demonstrated how AI-generated 3D meshes can be used to design a complete environment in Unreal Engine. Ultimately, you have to be the judge of whether that level of quality is satisfactory for your project. But also this technology is moving at a lightning speed. Tools like Meshy AI have evolved a ton since I made that video, and the results we are going to see today are also significantly better than what we had before. But that is not the point I'm trying to make in today's video, because this is not the only way to use a 3D mesh in a game development pipeline. There are so many other powerful and creative ways to use it, especially when you are working inside Unreal Engine. That's exactly what we are going to break down today. First, we will dive into what is for me the most exciting workflow: characters. I will show you how an AI generated head mesh can be fed directly into the Metahuman animator plugin to drive the creation of completely custom high fidelity characters. Then we will tackle world building, where we will see how a unique 3D mesh can be used as a stamp in tools like Gaia to create highly customized terrain height maps that we can import in Unreal Engine and use for landscape generation. For visual effects, we will jump into Niagara, where even a rough piece of AI geometry is all you need to create spectacular mesh-based particle systems. We will also look into creating fully rigged characters using AI, where you don't need facial animations. Alright, so let's jump right in. I created a realistic face image using ChatGPT and then generated a 3D face mesh with Tripo 3D. In my experience, Tripo sometimes produces more accurate face meshes than Meshy, so it's worth trying both and picking whichever gives the best result. Once the mesh was ready, I imported it into Unreal Engine and used the Mesh to Metahuman plugin to build a Metahuman identity asset. I have already covered this workflow in detail across multiple videos, so feel free to check those out for a step-by-step breakdown. Once that was done, I created a new Metahuman character. In the head section under Confirm, I added the Metahuman identity we just generated. This conforms our Metahuman's head to match the identity solver. I will also adjust the body proportions as required since the character is a woman. Next, I assigned the skin tone and started adjusting various parameters to fine-tune the facial texture and color tone. This step helps in shaping the overall facial profile of the character to more closely match the original reference image. Now the face might not look exactly the same, mainly because of texture differences, but you will notice the overall geometry and facial structure are quite close. From here you can fine-tune the features further to match the original image more closely. For the highest level of accuracy, you will need to create custom textures, but even with the default ones and all the available customization parameters, you can easily tweak the face to resemble the source image almost perfectly. Now let's move on to a slightly stylized example, a menacing looking boy. For this one, both Tripo and Meshy produced equally good results. As usual, I imported the generated face inside Unreal Engine and created a new Metahuman identity. Then I used that identity to confirm a new Metahuman character. The facial geometry is highly accurate in this case. The only area that needs extra attention is still the texture, which you can easily refine in tools like Substance Painter to achieve a perfect match. The sculpting tools in the character editor are also incredibly flexible, letting you refine facial features to get as close to the original reference as you want. A skilled character artist can push these tools even further to achieve near perfect accuracy. For me, this is about as close as I can get to the reference, and honestly, as a solo game developer, that's perfectly fine for me.
Keep wiggling the mouse like that and you'll get carpal tunnel. Then you'll have to explain to a doctor that you got injured playing as a psychotic killer doll. Think of the paperwork, man!
So here in Meshy, I conceptualized variations of a rocky cliff surface and then converted the best concept into a 3D mesh. I didn't bother texturing it since I only need the geometry for terrain projection. In Gaia, I set up a minimal graph with a few basic nodes to generate a rough base terrain. Then brought the cliff as an object node to project the shape onto the landscape. Because this projection conforms to the terrain, the height stretches to match the base and won't exactly mirror the original generated mesh. To blend it more realistically, I will fine-tune the object node, adjust rotation for a natural orientation, and tweak scale and offset to precisely place it at the desired location. Alright, so now I'm adding an erosion node and connecting it to the object node output. This blur node is going to soften the original projection a bit. I will continue tweaking the parameters until it feels natural. Once I'm satisfied with the result, I will use a combine node to merge it with the earlier path that defined the base mountains. Let me add a final erosion node to smooth the overall terrain and give it a clean, polished, eroded look. This also will smooth out any artifact or rough edges that might appear when you import the height map into Unreal. Now in our existing terrain, let me add something a little more customized and interesting. So in Meshy, I generated a dragon skull and I want that form in the landscape. So in Gaia, I added another object node and imported the skull. I continued tweaking the rotation, the offset and the scale until the placement felt right. So next I ran a sharpen node to punch up the distinctive ridges and cavities of the original mesh, followed by blur and denoise to soften artifacts and help the projection sit naturally in the terrain. A light erosion pass then finishes the blend so that the skull reads like it has been weathered in place. I used a combine node to combine the eroded output with the sharpened output. And yes, this looks perfect. This completely resembles the actual mesh and also feels like it is part of the terrain itself. I again used a combine node to merge this graph with the rest of the graph. Remember that this isn't a deep Gaia tutorial, so if you want a full Gaia to Unreal landscape pipeline breakdown, I can do a separate video on that. Once I'm happy with the result, I will use this Unreal node to export this as a height map. So in Unreal, I imported it as a landscape. I have to reduce the Z scale to adjust the height of the landscape. And the result looks great. High fidelity with those custom 3D forms clearly visible in the terrain. So let's move on to our next use case, creating a rigged 3D humanoid character. I am saying humanoid specifically because most of the current auto-rigging tools still aren't great at handling creatures. They work best with characters that follow a human-like anatomy. So using the Nano Banana image generator model inside Meshy, I was able to generate these beautiful looking concept arts of a humanoid robot. And I picked the one I liked most to convert into a 3D model. Now keep in mind, this method doesn't support facial animation, so it's perfect for NPCs, enemies or background crowd characters where facial animations are going to be unnecessary. Okay, so the generation is done and look at this, it's an incredibly accurate 3D representation of the concept image. Now I will click on the texture button to generate PBR textures. You can really see the metallic shine of the PBR material here. Of course, once we bring this into Unreal Engine, we will have full control inside the material editor, where we can tweak roughness, metallic intensity and even swap textures to create a more unique look. But for now, I'm not too concerned about the material. My focus is on getting the rig and animation right. The texturing can always be customized later directly inside Unreal to match the game's visual style. Alright, so now I'm going to download this model. And inside the Mixamo, I will upload the downloaded file for auto rigging. Once you have uploaded the character in Mixamo, it will automatically detect the body joints. You just need to assign the markers to the respective joint locations. And then click next to start the auto rigging process. After a few seconds, Mixamo gives you a fully rigged character that is ready for animation. Now you can simply test out different animations to see how the rigged mesh responds. As you can see here, the animation plays perfectly, the movements looks natural and the deformation across the joints is clean and stable. Everything bends and stretches just the way it should. And after testing the character out, you can simply download it along with all the animations and import it in Unreal Engine and start working with it. Alright, so to build the ice spike particle effect, I would rather need a single base model of the ice spike and not a cluster of spikes that you are seeing over here. This was just meant for some rough ideas. I would rather need a single clean base model, so I will prompt for a single ice mesh to generate that. From here I will choose the concept images I like most and convert them from image to 3D. Alright, so here is the 3D mesh. I'm going to texture it. I also added one more variation. You can also retopologize the mesh to make even optimized version of this if you want. So once the mesh is imported in the editor, I will create a new Niagara system. Okay, so the first step over here is to add a mesh renderer and assign our ice spike mesh. So I will remove the modules that we are not going to need in this emitter. So next I'm going to scale the mesh incrementally because the ice spikes are going to gradually rise from the ground. So in the scale mesh size module, I will add a float from curve and gradually increase the curve value. The initial mesh orientation module is going to randomize the mesh placement along multiple orientation vectors. Instead of using a spawn rate, I will switch to a spawn burst instantaneous module so that all spikes appear at once. Now I will duplicate the emitter and tweak a few of its properties to get a variation, which helps the overall effect feel more natural and dynamic. In the material of the mesh, I will add a particle color and add it in the emissive channel so that I can customize the color of the mesh directly from the emitter. Now I am going to add another emitter. Let's choose the hanging particles template. This will introduce some subtle icy sparks that appear around the meshes as they spawn. Okay, so here is the lump of ice ground mesh I generated in Meshy. This looks fine over here, but let's see how we can make the most out of it in our existing Niagara system. So I added another Niagara emitter and in the mesh renderer I added this ground mesh. I'm going to continue customizing this further, tweaking the emitter properties until we get the desired result. Next, I used Meshy to generate some cool ice debris crystals that will burst out from the spikes when they erupt. Back in our Niagara system, I have added this directional burst emitter which will handle that. So in the mesh renderer, I'm going to add our new debris mesh. I also added a collision module because these particles need to collide with the ground after bursting out. Okay, so the fundamental setup is ready. Now we just need to continue customizing the properties of the emitters until we get the desired result. I'm planning to make further dedicated step-by-step tutorial videos on creating this kind of effect so that this process can be followed along more easily over there. In the meantime, if you want to take a look at this entire project, you can get the files by becoming a member on my Patreon. Okay, so the next particle effect I will create is a fireball projectile. For this, I generated some base firewall meshes in Meshy. At first glance, they look a bit rough, of course, but I'm not going to worry too much about that right now. In my Niagara emitter, I have assigned this mesh to the mesh renderer. Then to get that emissive boost, I'll set its color value very high to make it glow like a real fireball. To get it spinning, let's add an update mesh orientation module in the particle update section. This will make the mesh constantly rotate. Okay, so I'm going to add another emitter. This is going to add the sparks coming out of the fireball. I will customize the mesh emitter further, creating some non-uniform scaling and also having some random parameters in the rotation rate is going to make it look like multiple meshes are rotating at different rates. Okay, so now I'm going to adjust the color using the color from curve and also scale the color to push some emissive glow into the effect. Inside the material, I will add this Fresnel node to create that crisp outer glow for our fireball. Yeah, so this looks perfect so far. I'm going to create another emitter for the trail effect. I will use this dynamic beam template, which is a ribbon renderer basically. This update beam we don't need because I want some sort of motion in the particle update. I will delete that. So let's add an acceleration force. This gives the trail a bit of motion and direction, making the whole effect feel more dynamic and reactive. Next, I will tweak the color properties to match the color of the fireball and also adjust the beam width to change the shape of the beam. I will keep fine tuning this until I am happy with how the trail flows and blends with the rest of the effect. For our final mesh-based particle effects demonstration today, I am creating a portal. To give the portal a proper base shape, I generated this custom torus style mesh in Meshy. It's like a twisted ring with some extra depth and detail. Back in the Niagara system, this time I am using a static mesh location module that lets me spawn the particles directly along the surface of our torus mesh, so the particles perfectly trace the shape of the portal. So I will continue customizing the properties till we get to the final result. If you want to dive deeper into how to actually build this kind of portal from scratch, do check out my detailed tutorial on creating the iconic Doctor Strange portal effects. And of course, the most straightforward use of AI generated assets is as plain 3D meshes. You can also split complex objects into parts for simple logic. As an example, I wanted to create an animated butterfly in Unreal Engine. So I had the wings and the body generated as separate meshes, attached the wings to the body and drove a simple rotation to animate the flap. You can also start from an existing mesh and retopologize in your 3D application. Here you can see in Houdini I brought the base mesh in with a file node. First I added a smooth node to relax the harsh edges, then a mountain node to layer controlled noise over the existing shape. I can also use scatter points to scatter multiple different meshes on the surface of this base mesh, and if I want a complete retopology, I can convert the mesh into VDB, run VDB smooth, then convert VDB back into polygons. This regenerates clean topology at the expense of existing textures, so you will need to re-UV and retexture. The workflow is quite simple. Start with the generated mesh, spend a little time customizing, then export back to Unreal. This saves a lot of time that you otherwise would have used in creating this mesh from scratch. This also gives you precise control to fine-tune details and turn it into a reusable production-ready mesh at a fraction of the time and cost it would have taken from scratch. Alright, so that's it for today's video. If you want to get your hands on this exact project with all the assets we created, it's available right now on my Patreon page, so consider supporting by becoming a member. The link is given in the description. If you have got questions or want me to break down a specific pipeline next, drop it in the comments. Thanks for watching and I will see you in the next video.